Today we're going to learn about further areas. Within these two diagrams we can see that there is a curve and an x-axis. There are two intercepts on this graph, A and B. What we have created here is an area bounded between the curve and the x-axis. On this graph we have the same situation. The x-intercepts A, C and B have created areas bounded by the curve and the x-axis. We're going to look at some scenarios. Let's write some notes down. This is for scenario 1, which was the first graph. For graphs with two or more intercepts, there is an enclosed region or regions between the graph and the x-axis. The area bounded by the graph of f of x is as follows. So for this one, we know that the area is below the x-axis. So we know that we have to take the absolute value. So the area of this one is the integral between a and b of the function f of x with respect to x. And make sure you take the absolute value. We can see that this graph has only two intercepts, so only one integral is needed. Let's look at the second scenario. This time there are three x-intercepts, a, c and b. Because there are three intercepts, we need two integrals. The first one is below the x-axis, so we need to make sure that we take the absolute value. So the integral between a and c of the graph g of x with respect to x, take the absolute value, plus the integral between c and v of the curve g of x with respect to x. Let's run through an example. Example 1, we're going to sketch the graph of the function g of x equals 3 minus x multiplied by 2 plus x. We're going to find the area bounded by the x-axis and the graph of the function. First thing we need to do is find the x-intercepts. To find intercepts, we want to substitute 0 into the equation. So 0 equals 3 minus x bracket plus x. We can use the null factor law to solve this, which tells us that either 3 minus x equals 0 or 2 plus x equals 0. Solving these gives us x equals 3 or x equals minus 2. Whenever we're sketching a graph, we also need to give the y-intercept. The y-intercept happens when x equals 0. So I'm going to substitute x equals 0 into our equation. 3 minus 0 multiplied by 2 plus 0 equals 3 times 2, which is 6. So our y-intercept is 6. When we're sketching the graph, we must include those key points. So we have the x-intercept is 3, we've got minus 2, and we've got 6. What we're going to find when we sketch the graph, so we'll put x-intercept on there. We should already know that the equation is a quadratic. So we should know the general shape of any quadratic curve. Obviously, it's a negative quadratic. Now what we see here is there is an area bounded between the curve and the x-axis. And that is the area that we are going to find. As we can see, the area is above the x-axis on our sketch. So we don't need to take the absolute value. I'm going to set the integral now. So area equals the integral, we're going from minus 2 to 3, remember read from left to right, of the expression. The expression was 3 minus x multiplied by 2 plus x, and I'm integrating with respect to x. Now it's easier if I can expand this using FOIL. It would be much easier to try and integrate if we had individual terms. So I'm going to expand that using FOIL. So again, write it all out. So I'm going to expand that. Now I can do this quite quickly. Hopefully you're good at doing this as well. So x minus x squared plus x plus 6. And now I'm ready to integrate. Remember, when we integrate, we add power and divide by that new power. Add a power, divide by that new power. And remember, I'm integrating keep the integrals in the same order with the 3 at the top and the minus 2 at the bottom. Now I'm going to do the substitution. So firstly, I'm going to substitute in the 3 into this expression. So minus 3 cubed over 3, solve them, plus 3 squared over 2, plus 6 times 3. Take away, and now I'm going to substitute minus 2 in. So it's minus 2 cubed over 3, plus minus 2 squared over 2, plus 6 times minus 2. Alright, now I'm going to work all those out. I prefer to use fractions. And remember, if it's a non-calculator exam, that's what you have to do. So this expression here would be minus 27 over 3, 9 over 2 here, and 18. This bit here, minus 2 cubed is minus 8, so it would be plus 8 over 3. This bit would be 4 over 2, which obviously makes 2, and this minus 12. If you're going to add it without the calculator, you probably want to make them all over 3, fractions over 3, so make equivalent brackets to be able to have them. I'm going to cheat and use the calculator. I know that gives me 30.5, and the second bracket gives me 2 over 3. Calculating that tells me that I have 20 and 5.